The product that we're going to be talking about today is one of the most game-changing technologies I've ever seen. Our mission is to make software updates to air-gap defense systems so fast an adversary would never dream of engaging in a conflict with us.
Software is the true king of the battle because our current weapon systems and platforms are supercomputers relying on near real-time data consumption. So as an infantry guy, I had to deal with a bunch of different things outside my skill set. Troubleshooting small drones, targeting applications, all as a non-trained software engineer. And you pull that application you need onto your tablet, and then you go out to the platform that you need to update, and with a few clicks of a button, you push a software update.
Let's go here. All right, good afternoon, everyone. Thanks for joining us. I'm Bobby Anderson, the GM of Tactical Edge here at Defense Unicorns. Today, I'm excited to be here to talk about a new product that we just launched. I've spent a career bringing aerospace and defense products to market, including everything from military guidance systems and airborne satellite communication systems to on-vehicle cybersecurity products that are protecting our nation's most critical infrastructure assets. And to me, the product that we're going to be talking about today is one of the most game-changing technologies I've ever seen for meaningfully increasing our nation's defense posture. Before we get into the details of UDS Tactical Edge, I'll frame some high-level inputs on the company for those that have not been following us closely. So Defense Unicorns was founded to solve the fundamental problem of quickly and continuously delivering modern software to the DoD. So our founders are all ex-service members or contractors who've battled these problems every single day of their careers. That resulted in them starting and founding Platform One, Castle Run, and Space Camp, all organizations focused on bringing modern software capabilities into the DoD. When they left service and founded Defense Unicorns, they took all those lessons learned and built a defense-first, air-gap software delivery ecosystem from the ground up. So our mission is to make software updates to air-gap defense systems so fast an adversary would never dream of engaging in a conflict with us. So in short, we want to make software a strategic deterrent to global conflict. So let's quickly talk about the larger problem here. So today, the reality of the situation is that most modern weapon systems are not able to update their software quickly and reliably if a major conflict were to occur. In most cases, such as the fleet of Navy ships, the software you leave port with today is what you have for your entire deployment. We've seen examples of it taking over $1 million in 12 to 18 months for a single software update on a weapon system. Essentially, with UDS Tactical Edge, we created the pipe for bringing the latest software capabilities directly to the warfighter. So just imagine you're able to update the software on your fighter jet in less than an hour after landing, accounting for the cyber electronic warfare effects that you observed on your previous flight. Moreover, imagine being a warfighter and able to deploy the same software update to other aircraft or weapon systems in your affected region the very same day. Again, if a conflict were to begin, it's the warfighter, the soldier, the sailor, or the airman that will be required to maintain the mission capability or readiness of their systems, not some US-based, highly technical group of software-focused engineers or contractors. So with that, I'm going to hand it off to Darian. He's going to walk us through the product to better explain these details and how we're enabling the warfighter. Take it away, Darian.
Hey, thanks, Bobby. And I also want to thank everyone else on the call for taking time to learn about a critical domain within our national security apparatus, software in the Tactical Edge. So a little bit about me before I jump into the content. I was a Marine infantry officer for 8 years. I operated in infantry and reconnaissance battalions, so shoot, move, and communicate as a team. And then my final unit while in service was a joint unit made up of Air Force, Army, and Marine personnel for close air support operations. So throughout my time in the Corps, I learned a lot about what does and does not work in these denied, degraded, and disconnected environments, which we call the Tactical Edge. Tactical Edge is a broad topic in the DoD. The edge to me in the infantry is different than it will be for a pilot or a submariner. But today I'll be presenting 3 sections that will cover the breadth of experiences that people in the DoD have in the Tactical Edge. So we'll look at a service member's viewpoint, UDS technical overview, and a real-world application. Before we jump into those 3 sections, though, on this slide, we're going to talk about a few principles. So first up, you can see true king of battle. So this is principle 1. Combat is continually evolving. The king of battle has shifted from machine guns to artillery to air dominance in the GWAT, and now it is software. Software is the true king of the battle because our current weapon systems and platforms are supercomputers relying on near real-time data consumption. So from there, we go to principle two. Since software is king of battle, if left exposed, it is our Achilles heel and is the most likely and most dangerous course of action for an adversary to exploit. And then the third principle, service members are experts in their career field, not software, but they are the ones dealing with this software dilemma in the tactical environment. So as an infantry guy, I had to deal with a bunch of different things outside my skill set, troubleshooting small drones, digital close air support applications, and targeting applications, all as a non-trained software engineer. So this third concept is extremely impactful in how we developed our product with that service member in mind. So we'll dive into what our service members are experiencing today next. So anyone from in uniform has a shared experience. Starts in boot camp, discipline, rules, regulations. You move to tech school for entry-level proficiency. Then you join an operational unit. This is the building block process for all branches. So now put yourself in the boots of a junior air crew member who has recently graduated tech school and you're a mechanic on an assigned platform. So we'll use F-35 for this example. It's in the right-hand bottom corner over there. This aircraft is responsible for maintaining, or this aircraft is a supercomputer. So millions of lines of code. You maintain the aircraft, the physical maintenance, you're an engineer, but software is critical to its operations. Now, if your crew chief or platoon sergeant came up to you and told you there's a critical software error that needs to be patched, what do you do? Where do you start? You were trained in mechanical engineering, not software engineering. This is a problem we at Defense Unicorns are solving for. How those at the tip of the spear who aren't software engineers can deploy software securely and repeatably because they have to. They are the ones there at the tip of the spear. UDS is focused on abstracting the complexity away. So we're trying to remove all that complexity for the warfighter. Everyone knows how to work a phone, for example. Downloading and updating apps on your smartphone is second nature. So we're going to walk through a concept on the screen right now. So from left to right, you see UDS Registry, which is an OCI compliant registry, so Open Container Initiative, and that's running on a laptop. Then you have your UDS mobile app running on your government issued tablet, and then you have platforms that need software updates in the air gap. So back to our junior mechanic with no software skills that needs to update that F-35, how does this actually play out? Your Air Operations Center with software developers push an urgent software update. Your crew chief notifies you. You then go grab your government tablet with the mobile app on it. You run out to the hangar where there's a laptop with UDS Registry. You plug in this with a USB cord or you can connect, and you pull that application you need onto your tablet, and then you go out to the platform that you need to update, and with a few clicks of buttons, you push a software update. So the great thing about this process, nowhere during the sequence does the service member have to learn something that we don't do every day with our phones. You go to an app store, you select an app for download or update, and you have an easy, intuitive mobile app experience that you can get through under stress and in a time-bound manner. So this is a high-level flow of UDS Tactical Edge in action. Next, we're going to kind of look behind the curtain, and I'm going to give you a high-level overview of how UDS makes this happen. And then a reminder, after me, Wayne, the tech lead, he's actually going to do a demo. So a lot of concepts I'll bring up at a high level, he's going to reinforce with an actual demo of this product. So this slide has a lot going on, and this is a simplified depiction of what is happening behind the scenes with multi-node containerized operations. And this is why it's so important to have one product that warfighters can focus on instead of making them learn a ton of different products and platforms. We're abstracting the complexity away. So UDS has capabilities for each layers. You can see some of them broken out by layers. Registry at the application layer, UDS core at the secure runtime layer, and then for infrastructure and code and OS, Kubernetes OS and infrastructure, that's at the bottom for cloud, on-prem, or edge. So for today's call, we don't have time to dive into each feature, But if you do want to dive into the UDS more and learn a lot about these features, our secure runtime platform, UDS Core, is free and fully open source. You can go to our public GitHub or technical documentation website and read about all these different features that you see. For example, metrics, monitoring, logging, and learn more about UDS Core, our secure runtime platform. Next, remember this diagram because we're going to walk through initial setup, deployment, and packaging. So UDS from that last slide, the first day zero process begins with your existing environment, applications, and dependencies, which is integrated with our secure and portable runtime platform, UDS Core, which you saw on the last slide. UDS Core runs on any certified Kubernetes distro and is customizable to your specific IAC needs. From there, UDS Core packages your applications into a single software bundle that can be deployed anywhere. So that means from cloud, on-prem, to the Tactical Edge, we can support the full range of classification levels and environments. For those in the enterprise settings, you'll be using UDS CLI, a declarative CLI. For those in the Tactical Edge, you'll be using that mobile app, which I showed kind of on the tablet before, and Wayne will be showing later on this call. UDS is an end-to-end product that addresses all facets of the software delivery pipeline, and that's why it's so impactful. At the end, you can say at the end of this diagram, you see we support day 2 operations as well. So we kind of talked about the service member, the importance of software is king, and the pipeline of how UDS goes from day 0 to day 2. And now we're going to dive into UDS Tactical Edge and actually talk about what is happening. So take a few seconds and kind of just look at this screen, because this is what service members are going to be seeing. So you can see UDS Registry is kind of on the back of the screen. You go to an application store, you select your application, you download it, and then the forefront of the screen, you see the UDS mobile app. It's easy to understand that you click download and you can deploy software. It's intuitive and it's not restricted to data centers. We built our product for conducting operations, which we're going to dive into now. So this is going to be a practical application, not in 5-paragraph order, but pretty close to it. So for orientation, our friendly forces are conducting multi-domain operations in sea, air, and land. And the different services are all connected on the same software application baseline. And this is because it's enabling joint all-domain command and control, so JADC2. We have software developers who are stateside, and they have access to modern cloud computing technologies, and they have trained software engineers at that location. A key call out between these two locations is the software developers are outside the enemy's radar and weapon engagement zone, while our maneuver forces are inside that zone. This is a clear distinction when planning for our Tactical Edge software operations in denied environments. We cannot always rely on connectivity. And this goes into the next phase, our enemy. So our enemy has exploited a critical vulnerability in that shared application. So for JADC2. So this has severely degraded our targeting operations. We can't share our friendly or possible or known enemy locations. So we can't target and we can't maneuver on the battle space effectively. So for our concept of operations and scheme maneuver to solve this problem with UDS Tactical Edge, we're going to push a software update from those software developers outside that radar and weapon engagement zone forward in the battle space. The registry is running on our field laptop. So remember, this is just on a laptop. It can be in a stationary location, or you can throw it in someone's assault pack on the move. And for this scenario, UDS Registry only comes online when the application is ready, because this minimizes our detection and survivability within the weapon engagement zone. UDS mobile app then connects to the registry for the update. So your tablet connects, and then from there, the UDS mobile app has a transfer mechanism that allows you to push the update application to your desired platform or weapon system. And at this point, that CV is patched. So you pre-position the UDS tablet around the battle space, and you have the ability to push software updates quickly and efficiently. In the bottom left-hand corner of your screen, you see an arrow indicating mission feedback. And this is indicating that this is not like a one-time operation, but this is going to be a very frequent operation. Software is going to go down, and we need a means to connect, push software forward, and then move into air gap operations effectively. In the last graphic, you see the UDS mobile app and registry popped up all throughout the ballast space, because this is reinforcing a key concept that the individuals accomplishing the last mile software delivery are operators, like me in the infantry, not software engineers. So these need to be pre-positioned around the ballast space. All you need is a tablet and a laptop, and you're good to go. So for me, when I was in the infantry, this was very important. We were issued government tablets for our digital CAS, and a lot of times ATACS, which is a application in the military, would go down, and we would have to revert back to our maps, and it delayed our process and planning all the time. So a lot of people in uniform can relate to this. Just because software goes down doesn't mean the mission gets called off. What actually happens is the mission goes forward, but you're a degraded force and you don't have modern applications and software and technology to rely upon. So this is what Defense Unicorn's mission is, to make software available anywhere on the battle space that UDS is positioned. So I covered a bunch of different topics, and hopefully you got some of it, but I have Wayne here to support me, and he's actually going to do a live demo and reinforce all these key concepts that we talked about today. And with that, I'll hand it over to you, Wayne.
All right, thanks, Darian. All right, so I'm going to walk through a bit of what Darian had talked about with that concept of operations, and really kind of go through the different personas and how they integrate with kind of this concept of UDS Tactical Edge. So if you can see this screen here, say that I'm a software developer who's stateside, and there was a bug with my application, and I just got it working. And so this is the working version of this application. Once I actually get that completed, I can then, go through my normal development processes, get it up into the UDS registry on my side. And so if I go to the UDS registry, I can see that we have mission app here, and I can click on that and I can view it here and see that the latest version has been published to the registry. Flipping over to more of a site reliability engineer or security persona, I can go through the software bill of materials. I can see that it's a chain guard image. I can go through and see all the software that's on here, licensing information, all those things. I can also go and see the vulnerabilities for this image. And in this case, we haven't seen anything as of this morning at 10:48. And I can get a good sense of what this application is going to be before it actually goes out to mission operators in the field. And so let's take a look at a video of what that looks like once this goes from this registry out to a place that is disconnected out in the field with operators.
Deploy the software first at a time over the air to a tactical small drone here in Eastern Europe. First thing, let's check the mission application. We have it not fully functional running. It may be due to different reasons. Jamming, cyber attack. Returning to UDS application. You see that we can now download the application update that Wayne has uploaded to UDS Registry in state. To do that, I simply click in the update button. While it's updating, you can see the drone here. The drone is fully air-gapped and connected only to this tablet and is running the application we showed you. Once again, the application is not fully functional. We are updating it and we are aiming to resolve this. To do that, we are going to deploy updated software to the drone. By simply clicking the deploy button, we are pushing the update over the air to the drone and installing it. On your screen you will see the recording. It's installed, and in order to see it, we need to switch to the tablet, and it's fully functional now. Eugene, you're good to go. It's remarkable how simple it is and how easy was the deployment. I haven't seen anything like this in my lifetime. That's it from Eastern Europe. We would like to thank everyone in state for continuous support and allied partnership.
All right, so as you can see, applications can go places that most other cloud applications couldn't go when you use UDS Tactical Edge. And you can always have pulled that package from the registry via CI/CD pipeline if you were in a connected environment, but the mobile app allows you to download things and really operate in a very disconnected way. If we go back to my screen, that's not necessarily all that's happening here either. These application updates are self-contained updates that we can kind of move around and that will operate in many different environments. But another key part of that Darian had mentioned earlier that's important for kind of the developer and SRE persona is that there's this kind of operator behind the scenes that's creating resources and managing the cluster for us so that package can operate in each different environment. This domain name and all of the different things that we're actually created in here, these SSO clients and whatever else is needed for the application is created by UDS behind the scenes so that package can really go wherever you need it to be without additional configuration. And really this whole concept of UDS Tactical Edge is something that we've been building towards for a long time. And I'm gonna kind of walk through a bit of like the things that we've kind of started with and why they're important to this particular use case and what they're doing. If you're familiar with XARF, you may know about the old Defense Unicorns DOS games example. And really, again, this is based on the concept of XARF packages, which is now an open SSF project that we donated and is an open standard for packages to exist in. This is something that has all of your images. So if you have Docker images or OCI images, it puts those in there. It puts your Helm charts in there, any Kubernetes manifests you need, any additional configuration, all in a self-contained artifact. And this allows us to move these things around effectively and efficiently, and also gears it towards a declarative deployment. And why that matters is that you will know the end state of the application when you actually deploy it. So when I deploy it here on my laptop, you'll know what that application is going to do. And when an operator deploys it in the field, you'll know what that application is going to do. That means that the warfighter can rely on that application more. It'll increase reliability and quality of the application. And then it also means that it's easier to debug. Because we're actually running and testing these apps regularly in Kubernetes as if they were deployed in production. And that allows us to see issues, one before they reach the warfighter, but if the warfighter has issues, we can see them and replicate them more easily in our development processes and workflows. Going back to the UDS UI, another important part of this is being able to have visibility in your cluster. This is not something that every single deployment is going to need, but there are cases in partially connected or connected environments where it is very useful to have a live view into a running cluster. And so even if you have an asset that's out in the field, if you did have say a Starshield connection or some other ground station connection, you actually could use UDS UI in the Tactical Edge on, again, any of these things. They're all UDS, they're all UDS core, to actually be able to debug and diagnose pod logs or see resource restrictions or any sort of thing that's happening while your application is out and running in the field. And so that provides kind of radical transparency to how your application is running, allowing you to debug it and really figure out what's going on from the developer persona and kind of, put less workload really on the warfighter as they need, because they need to be focused on the mission, not on the application updates, not on Kubernetes, and not on all these other things that are behind the scenes. Another important thing to the UDS Tactical Edge, and this is what we call UDS functional layers, which you can kind of see here. You can see this is actually a full UDS core deployment with all of the layers and services that are provided. But not every application actually needs all of these layers. And from a certain security perspectives, you might not need all of these. And really practically what adding additional services to a cluster does for the warfighter is it really increases your resource needs, and that increases the size, weight, and power of whatever device, whatever system, whatever thing they're carrying around with them or that sits on that vehicle. And that reduces overhead for the actual application that's trying to accomplish the mission, or it's just extra weight that the warfighter has to carry around. And so what I'm going to do here is actually remove these. And so behind the scenes, I'm removing the bundle that has the backup, the runtime security, the monitoring and metrics and log aggregation, because we don't need them for this particular environment. And you can see that we're actually getting rid of these things, and you can see this happening in real time. If you notice, the resource needs are actually going down as well. We're already down a whole gigabyte, and you can see that this graph is rapidly dropping. And so once we're kind of settled out here, you'll see we'll get to around 2 or 3 gigabytes. And this is with our mission application still running. This is with Keycloak and identity access management. the registry, runtime, service mesh, and policy engine all running. And so that allows us to really tailor our deployments to what is actually needed in the tactical edge and what is needed for them to meet the mission and what is needed to meet security requirements. And then another important part of this, kind of going back to the registry, is that we've kind of started changing around things to lean more into what we call kind of OCI ops as opposed to kind of Git ops. A lot of people in the DevOps world are familiar with Git ops, where you can, obviously sign your Git commits and you can merge those into main, and there's a whole PR review process and all of those kinds of things. But one of the issues with that in disconnected environments is when you need to be very careful about where your artifacts are coming from, where your images are coming from, where all of the different things that your Helm charts may be referring to are coming from. Because when you may need to roll back or you need to deliver an update, you need to make sure that you're delivering all of that together. And if, say, an image tag for one of your images has been deleted from whatever registry it was pointing to, or you're not pinning the ashas and the registry has updated the tag and the tag's now overwritten, you might not be deploying the exact state that you actually had previously, and you'll run into issues, and then an SRE will have to get involved and manually do a lot of different things with the cluster. But by each of these applications being a self-contained mission, a self-contained OCI artifact, this can be signed, it's versioned, it's tagged, and you really only have to care about one thing: the registry. As long as the registry is correct and that the registry has the data, has the versions and tags and various things that you need for your mission, then that's it. It's all there. There's no going out and reaching out to other artifacts, other things, and you still have the publishing, the signing, the versioning that you have with Git. You just have it with your code and all of the artifacts behind the scenes as well. And then lastly is the actual UDS mobile app. And so if I go ahead and we can watch this here, we've got the mission app. I'm going to remove it from the cluster just on my computer here. So we'll do that. So it's gone. And then I'm going to pull in the actual Android app here. And so this is running in an emulator, but you can see I'm actually connected to this registry here. And so I can see all of the application apps that are actually here. So you can see that there's Archivista and Core and everything else. And then if I were to go ahead and take, say, this mission app, I can click this, I can click download. This will go ahead and pull it from that registry to this tablet. Now it's fully downloaded. And I can switch over from the device side, which is really caring about downloading from the registry, to downloaded, and go over to the remote. And then I can click this, and then I can click deploy. And then you'll see that that winds up going there. And now the mission app's back. And we can click this, and it's still coming up. And then now our mission app is back in the cluster. And so you can see that this kind of enables a very easy flow to be able to have that on the tablet. And obviously I could download it from the registry to the tablet, walk the tablet wherever I want, the data is here, and then deploy it to whatever cluster needs to be deployed on the other side. The other part of this that's important for kind of the warfighter and disconnected operations is getting some of that feedback that Darian had mentioned. If one of these things goes down or dies, you need to be able to get logs and information back out of it. And so the Android app also supports that as well. So we can actually export logs, pod logs from the running cluster. And so even if we were in a completely disconnected, environment, we can go ahead and save that. And now that is now stored on the tablet, that snapshot in time for when things went wrong, so that I can now take that information and bring it back to the actual developers and then complete that life cycle back through. So really this enables kind of a very easy way to do a lot of disconnected operations, to work with warfighters, reduce the context burden on the warfighter, and be able to operate much more flexibly with your applications. Of course, UDS also supports the cloud, supports CI/CD workflows and all of those things. So the same applications can work in both cases. But this really just shows how you can really work in places that are completely disconnected, completely unreachable from the normal internet. And with that, we'll open it up for any questions.
Yeah, just looking at some of the questions, Wayne, I see, there you go. Jeff's been answering a lot in the background for us, but yeah, we'll go through the ones that are selected here.
Yeah, so the software updates are unclassed that I showed you here, but obviously mission applications could have whatever classifications that the mission application is at. So it really depends. Obviously, when you're doing this with a tablet, you're going to need a copy of the UDS registry at the same classification level as the other side of the asset, because the tablet's going to be going back and forth. But the beauty of OCI is that, again, it's self-contained, and many, like even cross-domain solutions, support OCI these days. Some of them do. So you could potentially mirror it up through an ADOS diode or whatever you need to if you needed to operate those higher classification levels. Does the app have runtime encryption? Yes. So this is running on our little friendy here. So this is actually running with TLS, if that's your question. And that's provided by Istio as well. So that's not necessarily something that I had to configure. That's something that the UDS core did. We don't have localization today, but it is something that we can look into. These are Kubernetes apps right now. And while we're not talking about it completely yet, we do have solutions that do things lower down, where we can deliver OS updates via OCI as well. But we have not fully productized that to share it. But I'll give you a little preview, or yeah.
A little teaser from Wayne there.
Yes.
Okay. Any other questions here coming out of the chat? Yeah.
Yeah, so right now we have explored Talos, and it's something we could support if somebody really wanted it. The big reason why it wasn't on the list is that we're targeting kind of a lot of what authorization officials are already familiar with, given they're going to want things like STIGs to be implemented, and it's much easier for us to basically provide them something that they're familiar with. So that's why we're kind of going with what we have right now. But we could support Talos if it was something somebody wanted.
All right. Any late questions coming in? I think that's it. Yeah. Okay. I'll just wrap us up. Just say thank you for everyone joining us today. Obviously, we're very excited about this new product launch. You can see at the bottom there if you want to reach out and get more information. There's a hyperlink to contact us and start a conversation. Obviously, if you got very specific discussions or interests, you can feel free to reach out anytime. We'll be happy to connect with you and talk all things Tactical Edge. So again, thank you, Wayne. Thank you, Darian. And thanks everybody for joining us today.
Thanks.
Thanks.